Why is latent heat key to the vapor compression cycle? Have you ever wondered how refrigerators and air conditioners keep things cool? The secret lies in a process called the vapor compression cycle, and a key player in this cycle is latent heat. So, why is latent heat so important? Let's break it down. Latent heat is the heat absorbed or released when a substance changes its state, like from liquid to vapor, without changing its temperature. In the vapor compression cycle, the refrigerant goes through two main phase changes: evaporation and condensation. During evaporation, the refrigerant absorbs latent heat from the area that needs cooling. Picture this. The refrigerant starts as a low-pressure liquid and, as it absorbs heat, it transforms into a vapor. This phase change requires a lot of energy, known as the latent heat of vaporization. As the refrigerant takes in this heat, it cools down the surrounding space, making it feel refreshing. Next comes condensation. After the refrigerant has absorbed heat, it gets compressed into a high-pressure vapor. When it reaches the condenser, it releases the latent heat it previously absorbed. This heat is transferred to the environment, warming it up. This process is essential because it allows the cycle to expel heat from the cooled area, keeping your fridge or air conditioner working efficiently. Now, let's talk about efficiency. The latent heat involved in these phase changes is much greater than the heat that causes temperature changes without a phase change. This means the vapor compression cycle can move large amounts of heat with only small temperature changes in the refrigerant. This efficiency is what makes refrigeration and air conditioning systems effective. Pressure changes also play a role in the cycle. The compressor raises the pressure and temperature of the vapor, while the expansion valve lowers the pressure, allowing the refrigerant to evaporate at a low temperature. These pressure-driven phase changes depend on latent heat to absorb or releases heat at a constant temperature. This ability helps maintain the desired temperature levels in your cooling systems. In practical terms, without latent heat, the refrigerant would need to rely solely on temperature changes to absorb or releases heat. This would be much less efficient and would requiring larger temperature differences. The vapor compression cycle's dependence on latent heat allows it to cool spaces or heat water effectively while keeping the refrigerant within manageable temperature ranges. So, the next time you enjoy a cool breeze from your air conditioner or open the door of your refrigerator, remember that latent heat is the unsung hero making it all possible. It enables the vapor compression cycle to work efficiently, ensuring your comfort in various applications.